So let's take a look at a couple of other similar storage arrays. And I guess it doesn't really matter, but it's good to have an idea of what else is out in the market so you can kind of compare. So there are other similar all-flash arrays out on the market, and a lot of these are being built by startup companies. So flash has been this great disruptor within the storage industry, and it's caused a lot of new offerings to pop up. But the features and functions do vary, sometimes greatly. Other options such as compression, you scale up against scale out, better like quality of service, all sorts of different things to kind of differentiate in this market. So a couple of examples. One is Pure. Pure is a very popular option out there, a startup company, and they follow a scale up mentality, meaning they have two storage controllers and they always have two storage controllers. And as you add capacity, you just add disk shelves. Pure also does a few other things like compression and several layers of dedupe. Again, slightly different. You always with the same controllers. You don't scale out in a node-based architecture like XBrick, but it is a pretty simple setup. IBM Ramsan used to be owned by Texas Memory Systems. Kind of popular, not as popular as it used to be. It was a bit of an aging product, used memory cards, internal cards instead of SSDs, which drove the price up, but did have some interesting features, mainly being able to mirror across two devices, things like that, but is really starting to show its age, and it's hard, it's having a tough time, I think, competing price-wise, because everybody else, like the Pures, like the Extreme IOs, like some of the ones we're about to talk about, have moved to more of the commodity SSDs for storage. Cisco Invicta. So Cisco bought a company called Whiptail, another startup a while back, and introduced what's known as the Invicta line. Invicta comes in two flavors. There's the 2U appliance, which is actually the picture there on the right, and it's an odd system. Well, I won't say odd, but it's the unusual one in the group here, as it's a single controller setup. So it's running on basically a 2U C240 rack mount server from Cisco, and rack mount servers only have one motherboard in it, which means one controller. Cisco also offers a very resilient scale out system. So it uses two front end C240s to what we call routers for input and output to and from hosts, and then those are connected via an InfiniBand pair of InfiniBand switches to some back end C240s called storage nodes. So you can scale out those storage nodes for capacity and resiliency as well as performance. So it's an interesting model in that it's all broken out into separate servers. Interesting system, allows you some flexibility, but is a little bit more complex since those controllers are out, the storage nodes are out. It's not as simple as just adding nodes, but it is kind of a scale out model because every time you add one of those router nodes or storage nodes, you get more CPU. Violin is kind of along the lines of Ramsan. Was very popular more early on, but is starting to fade. Again, just competing with newer technologies with cheaper commodity hardware. And then you have hybrid arrays. So a lot of people get these confused with all flash arrays, but a hybrid array such as a Tentry or a Nimble has both SSDs as well as spinning hard drives. And the long and short of it is that it'll have flash disks on the front end. Basically, any data that will come in to the array will normally land on either flash or some form of like NVRAM in the case of Nimble, and then get destaged to the back end spinning disks. This front end fast memory allows for high performance without having to go all flash. They also use the flash memory for read caching as well. And honestly, these things perform very well. They're not going to give you as great a performance as an all-flash array. They're not going to give you the guaranteed performance of an all-flash array, like less than a millisecond on Extreme IO almost no matter what you throw at it. But they are significantly cheaper. And as long as you're not doing anything too crazy and go outside the bounds, they perform reasonably well and have become very popular. So that's a couple of options here, just kind of how things stack up across the industry. And, this is ever changing, so there's always new entries coming in. So we've talked about bricks a few times through this lesson already. Bricks are this fundamental kind of building block for Extreme IO. You can start with one brick, you can go up to 4 bricks right now. But what really is a brick? So here we have a picture of 2 bricks. There's one on top, one on bottom. And a brick has the 2 controllers. You'll see there's one on top with the kind of the little bluish green little things. Those are actually SSDs that are sitting in there, used for metadata caching, or I'm sorry, metadata storage and booting. The actual controller OS is on some of those flash drives. Normally there's only a couple of them in there. And then you've got the shelf of 25 discs with the little orange tabs right there next to the one XBrick, and another controller below it. And below that is an InfiniBand switch. So I'll give you a little bit of word here. This picture is actually not correct. This was the original shipping configuration of Extreme IO. It shows here 2 InfiniBand switches, one on the left, one on the right, in a single 1U kind of unit. That has changed. And I can't find a good graphic showing that. So I wanted to show you the rest of the components, but unfortunately this one was slightly off. The way it is now is that each InfiniBand switch is a 1U in itself, and they've gone larger. So I think these are 8-port switches is what it looks like there, and they've gone to 16-port switches. So they've had to go to a larger unit. So what you'll normally see is 2 1U InfiniBand switches, and EMC highly recommends leaving 1U of space between the switches for cable management. So fortunately I couldn't find a great picture of that yet. It's a recent change, so unfortunately it's not there. And then on the bottom we have the second XBrick, and just basically the way that we would stack them. So what is inside a brick? So here's another diagram without the InfiniBand switches, since it's only 1 brick. So you have your 25-slot disk enclosure, what we call a DAE, disk array enclosure normally. And it holds 25 2.5-inch eMLC solid-state disks. The 10 terabyte unit uses 400 gig disks. The 20 terabyte unit uses 800 gig disks. But other than that, it's the same configuration. There are a pair of what we call battery backup units, BBUs. These are here because simply EMC doesn't trust your UPS. And for good reason. We've always heard of UPSs failing or generators failing. So they have these external to the system. And the idea is during a power failure, it'll alert the controllers. The controllers will destage what we call the metadata engine to the local SSDs inside each of the controller. And we'll try to do as graceful shutdown as possible. There is talk of integrating these inside of controllers, but as of right now, they are external. Again, not a big deal, but I'm often asked, why do we have those? But it's also not uncommon. Many other storage arrays have separate battery backup units, but there you are. You get a pair of these per pair of bricks, meaning when you add your second brick, you don't get any more battery backup units. When you add your third brick, you'll get another pair, and those will also support the 4th brick. So if you go 4 enclosures, or 4 bricks, if you do 4 bricks, you have 2 pairs of battery backup units. And then you have controller and controller. So those again are 1U servers running Intel processors that connect to the DAEs. And on the back, they have InfiniBand ports to talk to each other. And then they have fiber channel and iSCSI ports to talk to your hosts. There is an optional hardware, what's called XMS or Extreme IO Management Server. So if you do utilize that, you'll add another 1U server. Looks a lot like the controllers, just doesn't have the FC and iSCSI ports in it. And it'll run the management system. But everyone, as far as I can think of, everyone that we Vero have implemented has used what's called the Virtual Appliance XMS. And that is just a virtual machine running under VMware or Hyper-V or something like that, and does the management. But some people do want a physical management server that's in a rack and probably secured and segmented differently than they would a virtual machine. So that is an option, and you only have 1 XMS, hardware XMS, per cluster. So you can have 4 bricks and only 1 XMS. The downside to that is you only have 1. If it fails, it has to be repaired. But if it fails, it doesn't take anything down. You just can't make changes. You can't look at statistics but the I/O to and from the host and all that stuff still works fine. So again, that's one reason we see people do the virtual. They can use the protection such as VMware HA and fault tolerance, stuff like that, to protect that machine a little better than you can a physical XMS.